All right, let's take a look at what is going to be on the test here for solving quadratics. Now, before we get started solving using the three different methods, I want to talk about when we just have something as simple as x squared equals 72, because you might get a square root with a 72 under it, with a 24 under it, with a 48 under it, something where you have to simplify that radical. But just solving number one, a nice simple little square root problem. When we take the square root of both sides in order to isolate x, we're left with root 72, and that is not a perfect square. So we're going to need to break up root 72 into a perfect square times something else. Now, the perfect square happens to be 36 times 2. But maybe you don't recognize the 36 right off the bat. Maybe you're thinking of 8 and 9 to make 72. But that 8 can be 2 times 2 times 2, right? And 9 can be 3 times 3. So when we're looking at all the factor pairs here, a 3 could come out and a 2 could come out. 3 times 2 is 6. And then leaving a square root of 2. Well, that's where this square root of 36 comes in. So the biggest perfect square factor that's within a 72 is 36. So the square root of 36 is plus or minus 6. Root 2, nothing else can be done. So there you go. So just to reiterate, if you don't see the 36, break up the 72 into smaller factors. So 8 times 9, then break up the 8, 2 times 2 times 2, then break up the 9, 3 times 3, and look for the pairs. A 3 can come out, a 2 can come out. What is 3 times 2? There's where I get my 6. Nothing else to match with this 2, so it stays underneath. I hope both of those ways, one of them makes sense to you that you can use. Okay, here we are on the next one. It's only 2 terms, and they're not perfect squares. So we're going to use greatest common factoring here, looking for what's in common between each term. Breaking this down, do you see that there's a 6 in common between them both and an x in common between them both? The 6 and the x goes out front. The 2 minus x, I'm sorry, hang on. 2x is your term in front because they're in the same row. And then minus. And then back here, since the entire 6 and x were used, we need a 1 to hold that place. And just to double check, 6x times 2x does give me 12x squared. 6x times negative 1 does give me negative 6x. So here are my factors. Now notice that it's asking us to solve by factoring, taking square roots, completing the square using the formula. So I need to keep going. Using zero product property, setting each piece equal to 0, I'm going to get 2 roots, 2 solutions, 0 and 1/2. So my 2 roots, my 2 solutions are 0 and 1/2. What did I just find? I found that if I was graphing this, it would be touching at 0 and it would be touching at 1/2 for my parabola. Okay, let's look at the next 2. Notice that this one is perfect square factoring. Even though it's 2 terms like this one, there is not anything in common that can come out, but it is 2 perfect squares. For example, 16x squared is like saying 4x squared, and 225 is like saying 15 times 15. So do you guys remember that because this has no middle term, we're going to go 4x times 4x to make the 16x squared, and 15 times 15 to make the 225, and it has to be 1 plus and 1 minus, so that if you multiplied this, the 60x minus 60x would cancel out a middle term, leaving me just this result. Now that I have these 2 factors, now I can solve, setting these both equal to 0 by zero product property. I'm going to get a fraction of 15/4. And over here, I'm going to get a fraction of negative 15/4. My two roots, my two solutions are 15/4 and -15/4. Now, if you are not recognizing this one yet, I recommend you look up videos on the difference of perfect square factoring. This was section 4.4 from last unit. Okay, on this next one, we look to see if there's a greatest common factor, and there is. So here, a 3 can be divided out of everything before I get started. So with the 3 divided out, it leaves me x squared minus 4x minus 21. And then we're able to factor this with the usual just x. So what times what equals 21? Which one gets the negative? All right, now I have my factors. Now, since the 3 that's in front does not have an x with it, there is no additional root or anything that we need to solve for there. We essentially just ignore the 3. Only when there's an x with that greatest common factor do we have to solve it. Here there's no x, so we ignore it. So I'm going to solve this guy and this guy by zero product property. I'm getting x equal to +7 and x equal to -3. Those are my two roots, my two solutions. All right, number 5 needs a little bit more space than what they've provided here, so I'm going to try to squish it in. Number 6 is just square rooting both sides because it's already set up as x plus 3 squared equals 8. So if I square root both sides of this one, I'm going to get x plus 3 is now taken out, and then plus or minus root 8. So -3 plus or minus root 8 can still be simplified. 8 can be broken up into root 4 times root 2. So the square root of 4 is plus or minus 2. So this final answer is -3 plus or minus 2 root 2. There are my two roots, my two solutions, my two zeros. Okay, number 5 needs more space. Let me see if I can find some space for it. Okay, I'm going to do it on the next page. So 3x squared minus 5x minus 2 equals 0. Okay, here we have a trinomial, or 3 terms, where there is a number greater than 1 right here. So when we have a number greater than 1 and we try this x factoring, we now have to say 3 times -2. And that's what goes in the top. It's not just a -2 this time, there's a 3. 1 times 6 makes -6. Which one gets the negative? Right here. When I go to write out these factors, it's not just x plus 1 and x minus 6 anymore. Because there's a 3, a coefficient greater than 1, we have to put that 3 in there, and then we have to reduce these factors if possible. This one cannot be reduced, but this one can. Now we just solve 3x plus 1 equal to 0 and x minus 2 equal to 0 by zero product property. This one's going to give me a fraction. And this one is going to give me a nice whole number. Here are my two roots, my two zeros, my two solutions. Okay, for this one right here, I don't know if you've recognized this, but this is a perfect square trinomial, this x squared minus 8x plus 16. So this right here can already be put into a perfect square factoring format. And then we just square root both sides. My two roots are 4 plus or minus root 7. Finally, there's no greatest common factor to come out, so let's test this out. What times what makes 3 and adds up to -4? So think about this one for a second. What times what equals -3 and adds up to -4. Okay, this one cannot be factorable. When something cannot be factored, what is our method? We could do completing the square here because there's an even b, but look at the 3 in front. I don't want to do complete the square on 3 squares. I would need to divide everything by 3. That's going to be ugly. We need to do the formula. So getting A, B, and C. So -4 became +4 at the front. 2 times 3 on the bottom became 6. -4 squared is a +16. Negative times negative is +12. This becomes 4 plus or minus root 28 over 6. And root 28 can keep going. Take a second to see if you can, how far can you get with this? So then root 28, breaking that down, would be root 4 and root 7, or 2 root 7 as the final simplified version. So 4 over 6 plus or minus 2 root 7 over 6, and that can be simplified down to 2/3 plus root 7/3, and or you could write the whole thing as 2 plus or minus root 7 over 3. Finally, number 9 asks us to use the quadratic as well. I'm going to start a new video just so I break these up a little bit, starting with number 9.